Hi guys, welcome to the 2024 mock exam for physics electricity. In this video I'm going to try and cover the whole of question 1 of this year's exam. Let's get started. Question 1, the ion drive. A group of students have designed an interplanetary craft. Its working name is the NCEA MOA. Got all this information here, blah 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 blah. Alright, part A. On the diagram above, from the top to the bottom, not just near the hole in plate 2, draw the electric field between the plates, assuming that the hole is small enough not to affect the field. Label the plates as well, positive and negative. Okay, so we've got this here. Now, the way we can tell which side is positive and negative is by looking at this part here. Remember, the longer side always means positive, so that means this side is positive, which means this side has to be negative. Okay, so we can just start drawing our lines once we know that. So I'm just gonna, you can also like do some of these if you want, but they're not necessary. And some minuses. And we want to have straight lines, so I'm going to use a ruler, and let's just so we can have some straight lines. Okay, I'm just going to cut this part out and I'll skip to when I'm done. Okay, now that I've got all my straight lines, we have to remember the curved bits at the end. So I'm going to do a curved bit here and a curved bit here. And then we've got to make sure our arrows point from positive to negative. So we're going to have arrows pointing to the left on all our field lines. Okay, and that's all we need to do for this question. We've labelled the plates, positive and negative, and we've drawn an accurate electric field. So, somehow this question is actually worth a merit. You need to have, so, for merit, you need to have parallel lines. Okay, it needs to have arrows to the left. N and P labeled correctly, and straight lines and curved bits. So you need to have all of this for merit. For achieved, you just need to have parallel lines, arrow to the left, and the negative and positive label, so that is achieved. Okay, next question. Show that the strength of this electric field is 1.1 times 10 to the 5. Alright, I'll just pull up my calculator here. So we know the formula is E equals voltage over distance. So that's going to be, our voltage is 2000. Over our distance, which is 19 millimeters. So that converted to meters is going to be 0.019. And if I put that into my calculator, 2000, what is this? Divided by 0.019. Okay, that's going to give us 105 and 263,000. So if we just, you have to show the unrounded answer always. So what was it again? It was 263. Okay, whatever. 263.16 ... So if you round that, that becomes 1.1 times 10 to the 5, because our decimals 1, 2, 3, 4, 5. Okay, 5 spots, and that is a cheap question. You got to make sure you have the unrounded answer, so you must have this, or else you won't get the mark. Okay. Seth would like to know the force on the nitride ions and their acceleration as they move between the plates. Calculate the force and acceleration of the ions in the diagram, magnitude and direction, so size pretty much and direction. Magnitude is just a fancy word of what it actually is. Discuss whether these values will change. Oh, so we also have to discuss, great. If they will change as the ion moves between the plates, assume that the mass is constant. Okay. Right, there's a lot of things we have to do. I think what we should start off with is finding the force and acceleration, then we find the direction, and then we have a yap on whether they will change or not. So let's find the force first. So the force formula is electric field strength times the charge. So that's going to equal what we just found. So this, we'll just use this, not the unrounded answer. So 1.1 times 10 to the power of 5 times the charge, which is here. Now there's that little negative sign, but we always ignore that negative sign behind the 4.8. So you just write 4.8 times 10 to the negative 19, but don't ignore that negative. And that's going to equal 5.28 times 10 to the negative 14 newtons. Okay. Now, let's find the acceleration. So, F equals ma, so that will become A equals F over m. So that will equal the force, which is what we just found, 5.28 times 10 to the negative 14 divided by the mass, which is here. That's 2.326 times 10 to the negative 26, and that will equal 2.27 times 10 to the 12 meters per second. Okay, it's that question. So now we've found the magnitudes of the forces, so now we need to talk about the direction. Now, okay, if we go back to our diagram, we can see that the right side is positive, right? And the left side is negative. So we're going to assume if we get a positive answer, our force is going to go to the right. And if we get a negative answer, that means our force is going to go to the left. But if we look at here, both of these are, they're both positive values. There's no negatives. Okay, we're not worried about that power. So we can say the force and acceleration goes towards the right. Okay, because it's positive values. Okay, so now we've done the magnitude and direction. So now we have to discuss whether these values will change as the ion moves towards the plates. Alright, so usually when you do these explain questions, it's good to use your formulas and see what's actually going on. So using this formula here, okay, if I just write it down here, we can see the size of the force will only change if the electric field strength changes or the charge changes. But both of these will stay the same. The charge is not going to change and the electric field is not going to change because the distance between the plates haven't changed or the voltage or anything. Everything's still the same. So we can write the size of the force remains constant. That's just the same pretty much. Since F equals EQ, and E and Q remain constant, and you can also write uniform, like the electric field is uniform. The marking schedule, it's a bit more lengthy, but I've just sort of got the main points because I don't think I'll be able to fit it all in this question. So that's number 1. Let's go bullet point number 2. The size of acceleration remains constant since A equals F over M. Now we just said that the force is constant up here. So, and the mass, obviously the mass is not going to change. So it's pretty much the exact same things. Neither F or M changes. So A remains the same throughout the ion's motion. Okay, so that's all we needed. You can go a bit more in depth, but I've sort of got the main points. So this is a pretty long excellence question. There's quite a lot of things you have to do. It's sort of those explain questions and calculation questions combined into one. So for excellence, you need to have a complete answer. That means you've done everything. So you've found the two forces, you've got the correct direction, you've also explained why both the force and the acceleration remain constant, and you've linked it to the formulas. So excellence is full answer. Merit is the correct force, acceleration, and direction, or correct explanation. So just this is merit, or you could have had all this. Actually, all this is merit as well. And achieved is just anything, any one of anything. So just correct force, correct acceleration, or whatever. So just any 1 point.